Hello friends, I welcome you all to this session on graph theory. Today we'll be learning about vertex coloring. So, what is vertex coloring? Vertex coloring is basically assigning colors to the vertex of a particular graph. So, let's say I'm having a graph and I give different color to different vertices. That is what we call as vertex coloring. So depending on the number of color which I have given to the vertices or which I have assigned to the vertices, that particular graph will be called as K. That particular type of vertex coloring is called as K vertex coloring or vertex K coloring. So let us take in a particular graph, I have taken these colors, that is red, green and purple. Then what type of vertex coloring this will be called? This will be called as vertex 3 coloring. Okay. And if I have taken two colors, let's say green and black, then this will be called as vertex 2 coloring. Whereas if I have taken these four different colors, then this will be called as vertex 4 coloring. Okay. Now, we can assign colors to vertices, but this rule has to be followed. The rule says that no two adjacent vertices can have same color. So what are adjacent vertices? If this is one vertex, this is another vertex, then they will be called as adjacent only and only when they are having an edge, sharing an edge. So if this happens that these two vertices are having same color, then this is not the proper coloring method. Hence, this will be disregarded from this category. So in case of edge coloring, remember that no two adjacent vertices have same color. Now the vertices should be colored such that their adjacent vertices have different colors. This is the same. So this type of coloring is also called as the proper vertex coloring. So what is a proper vertex coloring? Proper vertex coloring means no two adjacent vertices are having same color. Okay. Now a proper vertex coloring of a graph is a vertex coloring such that the end points of each edge are assigned to different colors. And what are end points? They are nothing but adjacent vertices. So if you look this particular graph and I start coloring its vertices, then I give red to it. Can I give red to this vertex? No. This is adjacent. This no, adjacent. This no, adjacent. So only option left this. I can give this red. But let's say I am giving this particular vertex some color green. This purple, blue and orange. What I have done? I have used different colors to paint or color different vertices. So this is proper coloring method of vertices. Whereas if you look this graph and I start giving colors to it in this way, then this is not a proper method of coloring. Why? Because here in this case we are having two adjacent vertices which are painted green, and hence this is not a proper method of coloring. Okay, now comes the color class. It is a subset of vertices of a graph that contains all the vertices of given color. So let's say this is the graph and I have painted it with different colors. And now let's see that how many or what are the vertices which are painted blue. It is 1, 5 and 3. So this subset of 1, 5 and 3 will become a subclass, a subset of those vertices which are painted blue, and that is what is called as color class. So here the red is only painted on vertex 6. So this particular subset is the color class, one color class, that is red. Then comes blue and likewise green, that is it is painted only on vertex number 2 and 4. Okay, and this type of vertex coloring is what we call as, how many colors do we have used? 3. So this is vertex 3 coloring. Okay, very good. Now what is a chromatic number? This is a very important thing. When it comes to coloring, whether it is vertex, edge or graph, this chromatic number is very important one. So what is a chromatic number? Chromatic number of any graph, it is denoted by chi. This is chi. So it is denoted by chi g is the minimum number of different colors required for proper vertex coloring of graph. So what we'll be doing is, we will be starting with a particular color. we will be coloring vertex according to the proper coloring norms, and then we will be doing this, we will be repeating this process till that particular color cannot be further used. It is totally exhausted. Then only we will be switching to the next color. And if this is the procedure what we will be following, then we will be arriving at a particular number of colors we have used, and that will be the minimum, and hence that minimum number is what we call as chromatic number. So let us take these examples. Here, if you look this particular graph, let's say this one, top one. Now, so here I am painting red, let's say. Then can I paint this vertex red? No. Can I paint this vertex red? No. Can I paint this vertex red? Yes. Because this vertex and this vertex, they are not at all adjacent. Can I paint this red? No. Can I paint this red? Yes, I can paint this vertex red. Can I paint this red? No, because this is red, this is already red. Can I paint this red? Yes, I can. Can this? No. Can I? Yes. Can this be painted red? No. Can this be painted red? Yes. Now, if you look this particular graph, no vertex in this graph can now be painted with red color. The red color is totally exhausted. Hence, I have to switch to next color. Let's say I am now painting green color. So can I paint green color here? Yes, I can. Here, yes. Here, yes. Here, yes. Here, yes. Here, yes. So how many colors do I have used? 2. What is the chromatic number for this particular graph? It is 2. Similarly, if we look this particular graph, I start with, let's say, this vertex. Can I paint red here? No. Can I paint red here? No. Can I paint red here? Yes, I can paint with red color. Can I paint this as with red color? Yes, I can. Now, the thing is, the red color can no more be further used. Now, can I paint this vertex green? Yes, I can paint this with green color. Can I paint this with green color? No, because green is already used here. So, therefore, I have to switch to different color. Let's say I am painting it with black. So now how many colors do I have used? So I have used one, that is red, green and blue. So what is the chromatic number for this? It is 2. Here in this particular case, let's say I have painted this with black color. Can I paint this with black? No, I cannot. So I have to switch to different color. Let's say I painted it with red. Can I paint it with red? No, I have to paint it with green. So in this way, friends, you can paint different vertices using proper coloring method. That means no two adjacent vertices should be having same color, and at the same time the number of colors which you have used should be minimum, so that will give you the chromatic number. So in this way we color the vertices of any graph. So in this lecture till this point only. In the next lecture we will be learning about edge coloring. Thank you very much for watching it.